Hello everyone, welcome to HashiTalks. My name is Felipe Angelo Sgarbi. I'm a senior software engineer at Sgarbi, and today I'm here to share some of my experience in production about the use of HashiStack and how a simple change in paradigm resulting in a huge change in architecture that greatly benefits our customers. Before anything, I want to give a quick briefing of the company I'm working on. Well, Sgarbi is a car tracking, monitoring, and alarm platform aiming to put the safety of your vehicle in the palm of your hand. We currently attend over 30 cities across the entirety of Brazil, offering nationwide coverage while also providing support for over 300 vehicle models, from car, motorcycles, construction vehicles, and even jet skis. All this is boiled down and simplified to the user to make it trivial to manage the security of your vehicle, down to be as simple as pressing a single button. And one of the challenges of your current platform is the sheer volume of data coming in by the second. On a common day, we receive over 37,000 positions per day, containing info like the latitude or longitude, speed, if there was any kind of alarm, and water telemetry data. With this challenge in hand, we had to reevaluate how we deal with the architecture and infrastructure of our platform. For a long time, we have been using standard common servers running mainstream operating systems such as Fedora server and Ubuntu server. And with the discovery of the HashiStack, we got excited about what we could achieve with it. A more reliable platform that really could improve not only the development cycle, but also scalability. Yet, as we started to experiment with it, one thing quickly became visible for us from a technical standpoint. The HashiStack paired with common servers and a normal way to deal with servers was nowhere near enough. With difficulty of maintenance and struggles to keep up with the architecture were nearly exponentially. A shifting in how servers are dealt with was needed if we want to make use of the HashiStack. Well, most of you must be questioning why can't common servers keep up with it? And this is with their operating systems. The software that runs on the base of everything, the very foundation. Don't get me wrong, they are great, yet they still pose their own flaws. Mainstream operating systems for servers such as Fedora server, Ubuntu server, and Debian are made to be as flexible as possible, allowing you to do virtually anything you require to do with relative ease. Yet this means that this operating system have a lot of moving parts, a lot of gears in motion to make sure everything is working properly. And this put a challenge into maintenance and troubleshooting because the more moving parts there are, the more prone to breaking it is, making one of the biggest strengths into an unfortunate issue that might become bigger as time goes. A few of the common pitfalls of traditional servers that show these flaws come with the usual operation during maintenance. Especially with the misconfiguration factor, it may not be noticeable or effective when dealing with only a single server, but the moment you start scaling into multiple servers, it starts showing up. From forgetting to disable password authentication on SSH, not opening specific ports on firewall, or something as serious as a typo on some file name. This changed the way we see and treat servers. It calls for an overall change in the way they are dealt with. In the past, servers were just like pets. Carefully handled changes and updates were week-long, methodically planned, time-consuming tasks. And this change made us realize that servers instead are more like calls. It called for a way to quickly be able to set up a new server and be ready for production in just a few minutes. Changes and updates were part of something that closely resembled rolling releases, and at times stopped being a measurement of how successful the server was. With this in mind, we started research for new solutions, and what we came across was a new paradigm in the server space that is relatively new, yet the way it approaches servers came out as a huge innovation. For this next step comes a bit of story. Around 4 years ago, a new type of operating system surfaced, an open-source, lightweight operating system based on a Linux kernel and designed for providing infrastructure for cluster deployments while focusing on automation, use of application, deployment security, reliability, and scalability. In January 2018, it had been acquired by Red Hat, merged into Project Atomic, and later on was replaced by Fedora CoreOS. CoreOS is significant because it is a reimagination of the operating system in the context of a host role in the data center at scale. It does this by simply fully embracing the notion of Linux containers and immutability. It abstracts away the notion of a physical host instead of a pool of compute, because there is no theoretical limit to the numbers of hosts. In a pool, you can deploy containerized services simply and without the thought of the host area on. Essentially, it is now possible to reason about your application use 2,000 gigabytes in memory and 200 terabytes of local storage. I'm not thinking about the hosts. This is a significant simplification. It is a different way of thinking about the operating system, being much more akin to your mobile phone, for example iOS, than a traditional Linux machine, and that contains the effect and not the cause. The idea here is that you should be updating files, libraries, and patching stuff in your core operating system. You should be monkeying around your portable Docker container and getting a guaranteed to be accurate, stable, and up-to-date Unix OS to launch the services in. The neat benefits once you have a stable, guaranteed to be accurate operating system are plain. You can easily cluster machines because you won't will always act the same. With this in mind, the power of the HashiStack really starts to shine through. Having a rock-solid operating system that allows you to scale with minimal effort allows Nomad, Consul, and even Vault to be used to their fullest. The service mesh capabilities and KV store of Consul allow you to not only easily communicate between services hosted on these machines, but also Nomad can easily orchestrate what runs and where when ensuring that all containers are running accordingly. CoreOS pairing with the HashiStack launches a highly predictable, easily scale environment that can be replicated anywhere, be it a bare-bones service of cloud providers such as AWS, Google Cloud, or even Microsoft Azure, or even external VPS providers such as DigitalOcean or Linux. Yet, its biggest strengths come when paired to another tool from the HashiStack, Terraform. It's a bit of an understatement to say that Terraform works great with CoreOS. CoreOS makes Terraform feels like a superpower. Being able to set up every part and corner of not only your cluster but also the individual operating system from multi-point services to run and even to use this themselves. The capability of ISC that Terraform provides makes developing cloud-native solutions way easier than normal traditional servers. To give you a small idea of how powerful Terraform paired with CoreOS is, let's take a look at a small example. In this example, we are setting up a server with a single user. Here we are enabling via SSH key, setting up the time zone, and configuring the hostname. Itself, it might not seem much, but let's say we are setting up for multiple servers, let's say 10 servers. Imagine if we do all of this for every single server. Not only this would be 10 times more time consuming, but also prone to errors. You could end up mistyping the authorized key's file name, or mistyping the permission of the SSH key, or remove the default time zone, but forget to link the new one in place on the new server. Now, let's take a look at how CoreOS does it by itself. The way CoreOS configuration works is that you don't do it yourself manually. Instead, you supply a configuration file during boot or setup. This configuration file is generated from a built-in config file, which is by itself a simple YAML file. And to use it, the built-in config is compiled into a readable initial file for CoreOS. During the first boot, CoreOS automatically provisions all the configuration required, so once it is online, it is configured just the way you would expect, yet it still suffers from a few problems. If we were to, for example, set up 10 different servers, we will need to create 10 different configuration files and compare the initial files individually. It still involves a lot of manual work that could end up leading to mistakes. It is faster, but still prone to the same mistakes. And now the reason why CoreOS paired with Terraform feels like a superpower. Here we have a really basic Terraform file. Note how the code itself generates the initial file procedurally, allowing you to use things like functions and variables to change how Terraform generates the configuration. And even better, you can connect your favorite providers such as AWS to automatically deploy your CoreOS server with the configuration generated. This allows you not only to generate the configuration files you need to manually bootstrap the service, but instead bootstrap the service directly, reducing the amount of manual labor and making everything highly predictable. Need to replicate production into a KVM to debug some nasty bug that does happen in station, you can simply connect to your KVM provider and point it to your CoreOS configuration to it. With this in mind, pairing the HashiStack with CoreOS while using Terraform to bootstrap an entire cluster becomes such an elegant solution. A small running joke amongst the team at Sgarbi is that the HashiStack and CoreOS is a match made in heaven. The way it works is that Terraform bootstraps the infrastructure in form of servers running CoreOS, and inside it, it installs the HashiStack series of software. Nomad deals with running all of our softwares, In Podman containers, which is the default container technology that CoreOS provides, Consul deals with networking, service mesh, and key storage for things like configuration, and Vault deals with identity management and secret storage. All the HashiStack software is automatically set up by the CoreOS during the first boot, so once the server comes online, the node is already ready for production, and if something needs to be changed, simply edit the Terraform file and reapply it. Yet, it does come with a few gotchas. CoreOS is not perfect, it does need a few considerations to be used in production. The first biggest issue with CoreOS is that once the configuration is bootstrapped, it cannot be changed. Once you do put the server up and need to do a change to it, you need to rewrite the configuration or replace the installation altogether. Of course, nowadays closed providers make leverage this a breeze, and the natural load balancing nature of Consul service mesh makes this way less of a hassle, but it still makes this unsuitable for small clusters with only a single server runs specific software which all others depend on it. Yet, if this is not the case and one server going down for a few minutes won't affect uptime, they can be updated as a running release, and Terraform can apply the changes on a server one by one, waiting for one to come online before updating the next. Another issue that might also surface is persistent storage. CoreOS is an immutable file system, which means data persistence must be explicitly set up by you. Yet, this is where Nomad shines with its CSI technology. You can set up a content storage interface for providing storage volumes to your container, such as AWS Elastic Block Storage Volumes, or upload persistent disks, SAP, Portlocked, vSphere, or others. The best part of this is that you are not locked by the amount of storage in the server that the application is running, but instead have all the available space in your CSI provider in all of the nodes. Those familiar with Kubernetes might feel at home with this. Well, it has been mentioned, but what about updates? After all, CoreOS is an operating system just like any other, and at some point the base operating system will need to be updated. The beauty of CoreOS is that these updates are liberated automatically, since they work via streams such as stable, testing, and next. It leverages automatic in-place updates. In case of a failure or worst-case scenario, it can be rolled back to the latest working deployment without having to reformat from scratch. This is thanks to the fact that CoreOS provides atomic updates and rollbacks via OS3 deployments. For those unfamiliar, OS3 is an upgrade system for Linux-based operating systems that perform atomic upgrades for a complete file system tree. It is not a package system, rather it is intended to complement them. A primary model is composing packages on a server and to replicate them to clients. The underlying architecture might be summarized with a Git for operating system binaries. It operates in user space and will work on top of any Linux file system. At its core, it is a Git-like content addressable object store with branches or refs to track meaningful file system trees within the store. Similarly, one can check out a comment to these branches. One issue it has is that upon downloading and staging a new update, the server must be rebooted for the new update to take place. This can introduce downtime, yet Zincachi, the tool that continually checks for OS updates and applies them, can be configured with the rollout awareness value to control how eager or risk-averse the node is to receive new updates straight from the configuration. It also can control when nodes are allowed to reboot for the update's finalization. For example, configuring servers only reboot during the weekdays, starting at a specific time frame to reduce the risk of a server update disrupting server or downtime. A few questions might be lingering on everyone's heads, like why not Ansible, Chef, or Puppet with normal servers, or even why not a Kubernetes cluster? Well, a few key differences to show why HashiStack paired with CoreOS and Terraform might be a better alternative for you. For starters, the first question is about why not tools like Ansible or Puppet. Unfair. There are really powerful tools that allow you to leverage configuration of multiple servers with ease. Yet, what sticks with them is that these tools are configuration management tools, while Terraform is an orchestration and provisioning tool. Tools like Ansible are mainly used for configuring servers with the right software and updating already configured resources, while Terraform is the best fit for orchestrating cloud services and set up cloud infrastructures from scratch. The difference is that using Ansible as a default service instead of Terraform with CoreOS is that the latter won't require you to install the operating system from scratch before configuring everything. Terraform provisions the service automatically while CoreOS configures everything right at installation. Configuration management tools solve the issues locally rather than replacing the system entirely. Ansible helps to configure 8 action instruments and ensure smooth functioning without any damage or error. Yet, it still requires you to manually bootstrap the service or configure SSH access manually. Without it, the tool is unable to do its work. Meanwhile, orchestration tools insert an environment is in its desired state continuously. Terraform is explicitly designed to store the state of the domain whenever there is a glitch in the system. Terraform automatically restores and computes the entire process in its system after reloading. It is the best fit in a situation where a constant and variable state is needed. Terraform applies helps you resolve all anomalies effectively. Paired with the immutable nature of CoreOS, Terraform allows you to create an infrastructure that you can predict with ease and will always be at the same state every time. And the second question, why not Kubernetes? Well, it boils down to complexity. Kubernetes is a really powerful tool at the cost of complexity. Kubernetes is well known as a complex ecosystem with lots of moving parts, requiring configuration of numerous interdependent components to manage and deploy. And overall, setting up your own Kubernetes cluster can be difficult, while Nomad and HashiStack in general are significantly more simplistic and require way less configuration to be up and running. This is because, unlike Kubernetes which aims to provide everything out of the box, the HashiStack is specialized. Nomad only deals with scaling and running containers, while Consul focuses on service mesh and service discovery. With the HashiStack, you can simply skip the tool if you don't use it. Meanwhile, with Kubernetes, all parts must be running at the same time, even if only a few are being used at all. Well, in conclusion, the HashiStack is a really powerful infrastructure stack, but its real power shines when paired with an immutable approach such as CoreOS for a highly predictable environment. Not only can it be used in the early development and stage to be able to develop as close as possible to the production environment, but also in production to ensure everything will work as intended without hiccups or issues that may introduce downtime. For this, we at CMKR have set up a gift for anyone who would like to start playing around with HashiStack inside CoreOS with Terraform. We present Harbor, a Terraform configuration that can provision a CoreOS cluster of VMs inside a KVM server, automatically setting up the HashiStack software for ease of use. It is licensed under the GPL version 3 or later license, so feel free to use and contribute to the project. I hope this has been useful and could spark curiosity with other alternative deployments for improving the lifecycle of service with new and innovative paradigms for production. A huge thank you to Karen Saturday, John Hajilski, Kent Gruber, and the team at HashiCorp for the opportunity in participating here at the Hash Talks, and for the team at Red Hat and Fedora project for the inspiration and the amazing tool that CoreOS is. I also remain available at any time at my Mastodon alias for any question you might have. Feel free to reach out for questions, ideas, or to show up what you achieved with this concept. Until then, I'm Felipe Angelo. See you in the next Hash Talks.